One key parameter which is needed to calculate the OEE of a plant, but also has other noteworthy applications, is the ideal cycle time, or its reciprocal ideal production rate. Knowing the ideal production rate, a manager can calculate the production capacity of the plant in, say, 1 year of production. In the example of the OEE calculation, Giovanni estimated the time to produce one single brochure be 1 minute. But let's imagine that on top of the brochures, Giovanni also had to produce folded flyers with an ideal cycle time of 0.5 minutes per flyer. What would then be the overall ideal production rate? Let's consider, after all, that mono-product manufacturing systems are very rare. Most manufacturing systems are multi-product. As a consequence, production capacity is always calculated with reference to a given production mix. In a multi-product setting, it is useful to refer to a mix production rate, P mix. The P mix is the average production rate that allows a plant to produce a certain total production in a specific mix of products. This way, the passage from production rate to daily production capacity and vice versa would be seamless. Giovanni doesn't need to wonder how many brochures will I produce in a day and how many flyers. The right question should rather be, if I produced in a mix of 50% brochures and 50% flyers, what would the average production rate be? Now, I have a challenge for you. Imagine that Giovanni started producing 500 brochures at a production rate of 1 brochure per minute. He then proceeded with the production of 500 flyers at a production rate of 2 flyers per minute. Let's assume that there were no stoppages and that setup time was negligible. What would have been the average production rate? I guess most of you calculated the arithmetic average as 1 plus 2 divided by 2, that is 1.5 pieces per minute, as the mix is 50% brochures and 50% flyers. That's wrong. P-mix is the ratio between the sum of the quantities of different items that have been produced and the total time needed to produce them. Caveat: do consider that total time should also include setup times. The total count is given by the sum of good and defective pieces, G and D respectively, while the total time is given by the sum of time required to produce the total count plus setup times. In turn, the time required to produce the total count is given by the number of pieces of every item divided by each item's production rate. Let's go back to the challenge then. Giovanni produced 500 brochures and that took him 500 minutes. He then produced 500 flyers and that took him 250 minutes. So in total, Giovanni produced 1000 pieces in a total time of 750 minutes. That obviously make 1.33 pieces per minute on average. 1.5 pieces per minute, the arithmetic mean is wrong. It is always wrong. This formula is called harmonic mean. It is used to calculate the average speed or average rates, such as, in our case, the average rate of pieces per unit of time.